welcome you all once again for the session 2 of day 5 on topic Geomatics Engineering by Professor Anjan B K. Professor Anjan B K working as assistant professor, having over 6 years of teaching and research experience. He obtained his bachelor degree in civil engineering from Government Engineering College, Chamarajanagar, and master's degree in structural engineering from VTU PG Center, Mysore. He offered consultancy in design and entity evaluation for RC structures and also surveying in total station. In today's session, he will be speaking on geomatics engineering pertaining to GATE 2021. With a short note about the speaker and the topic, I request Professor Anjan B K to take over the session. Over to Professor Anjan.
Thank you, Rajit sir. Guru Brahma, Guru Vishnu, Guru Deva Maheshwara, Guru Sakshat Parabrahma Tasmai Shri Guruve Namah. I wish you each and everyone happy Guru Nanak Jayanti. And with this note, I take this opportunity to thank the VVC management to giving me an opportunity to share my knowledge on geomatics engineering to you all. And I also take this opportunity to thank the organizers of Civil Engineering Department from VVC Mysuru. With this, we are going to start our today's subject on geomatics engineering. So I take the opportunity to welcome you all for the GATE 2021 online training on geomatics engineering. And basically in the GATE in 2021, the syllabus is, you can see it here, the basic portion which I am going to cover is this portion we are going to cover in this session, and the second portion will be covered by my colleague Professor Girish P. He will be discussing on the second concepts here. So we will be focusing more on the first part here, where in the surveying, normally from the past 6-7 years, the questions appeared in the GATE is for 4 to 6 marks. So up to 4 to 6 marks, and normally they will be asking but nevertheless sometimes the questions are asked for 1 marks, two number of questions for 1 marks and another 1 question for 2 marks. And most of the case we can observe that the questions related to the distance and angle measurements, that is related to chain and compass, there will be one probable question, and related to leveling, normally related to leveling, there will be a second set of question which will be asked. So that is probability of asking the question, and in rare cases some problems are asked on curves, okay, and errors and their adjustments will be asked. If the question is asked on errors, so then there will be no question on distance and angle measurements, so like that. So with this note, we'll see what are all the concepts involved in the geomatics engineering. So first of all, you all know that earlier this geomatics we are actually calling it as surveying, but now in the recent years we are calling this as geomatics, that is measurement of earth. So we are dealing with measurements of earth, so it's called as geomatics. So basically in surveying, what we will be doing is we will be interested to collect the as much as data by measuring the earth surface. So that is the basic idea behind the geomatics. And in this, actually what we will be doing, we will be carrying out and finding these spatial locations. Either it will be relative or it will be absolute, means it will be with reference to some reference control points, or it may be with the temporary control points. So where it is feasible for a surveyor, he will be collecting all the details, and what he will be doing, the surveyor, he will be doing all the data collected will be represented in the graphical manner, that is through map or plan. And the primary divisions of surveying, we know that this is we all know that the shape of our earth is in spheroidal shape. That is, we have the surface of the earth is curved nature. So we need to consider the nature of the earth, which is in the curved shape. We need to consider that. Based on that, there are two primary divisions have been made. So one is called as geodetic surveying. So this is geodetic surveying, and the other one is plane surveying. So in geodetic surveying, normally in geodetic surveying, normally the curvature of the earth will be considered, whereas in plane surveying, the curvature of the earth is not considered. So when you are doing a survey for a smaller area, normally we will go for plane surveying, and when you go for a better, good, accurate work is needed, then we will be preferring geodetic surveying. So in geodetic surveying, this is the surveying which is preferred by Survey of India. So they will be preferred, the accuracy with respect to preparation of maps and all will be higher in nature. So therefore, so this geodetic surveying is the one which we'll go for when you need higher accuracy. And normally there will be a question on this. So whether the curvature of the earth is considered in plane surveying or geodetic surveying. So based on that, there will be a question. So let us have a look into this difference between the two methods. So in plane surveying, the earth surface is considered as plane. So as the name itself is, we are not considering the curvature. Whereas in geodetic surveying, the earth surface is considered as curved surface, means the curvature of the earth is considered there. So here the curvature of the earth is ignored, whereas in the geodetic surveying, the curvature of the earth is taken into account. And the line joining any two stations, if you join any line with a two station which are on the ground, which will be considered as straight with respect to plane surveying, whereas in geodetic surveying, if you connect those two stations, so we will be calling it as spherical. And in the triangle, if you are taking the 3 points and if you are considering all the connecting all the 3 points, and that will be called as plane triangle. And in the same way, in the geodetic survey, it is called as spherical triangle, means we'll be considering the length, breadth, and as well as the height, elevation will be considered, and also curvature of the earth is considered here. So the fifth one is the angles of triangles are considered as plane angles. So as I mentioned, means if you are measuring distance, it is straight distance. If you are measuring angles, it is plane angles. Similarly, in geodetic surveying, it is considered as spherical angles. And where this plane surveying is considered, it is actually used in the area where the area is lesser than 250 kilometers square. Where we will be preferring the geodetic surveying is, if the area is more than 250 kilometers square, there we will be normally going for geodetic surveying. So these are the basic difference between the plane and the geodetic surveying. Moving on, the next concept is on fundamental principles of surveying. So here we know that there are basically two basic principles involved in surveying. So that is, one is always we have to work from whole to part. So it should be always working from whole to part. It should not be in the reverse way. So to give you an example, so for example, you have a line, say a line AB is more than say 10 kilometers. So you cannot measure any distance between this line AB, which is 10 kilometer, in a single point or a single step. So that's what we have to do. We have to subdivide this whole work. This is the whole work. So this whole work has to be subdivided into smaller works. So you need to divide them into smaller parts. So, and after dividing them smaller parts, we need to we have to make sure that it should be in line. Whatever the points we are choosing, it should be in line with the control points. So this A and B are nothing but the control points. So this is the idea. In this, what happens, if there is some error, that error will be only in that particular area. It is not going to move to the next particular section. Whereas if you work from part to whole, if you do it in reverse way, if you start your work from A point and you go up to C point, then you will get deviated. So if you work with part to whole, then what happens, the total error will be accumulating. It will be accumulating, and you will be getting the total error at the end. You will be ending at somewhere. So this means the total length measured between AB will be increasing. So this is the basic first fundamental principle is you have to work always work from part to whole. And next principle is we have to locate. In order to locate any new station, we should have a minimum least of 2 measurements, which means before starting any survey work, we will be taking control points. So normally we will be preferring to take 2 control points. So with the 2 control points, what we can do is we can actually calculate, we can actually find out the third point. So for example, here, let us take 2 points, and the 2 points are say A and B. So in order to find a new point, the point C, so what we need to do, we need to have at least 2 measurements. We need to have 2 measurements. That is, either we need to have the distance from A to C, the distance from A to C should be known, or the distance from B to C should be known. This is one way. Or we should have the angle of this AC line and also the distance of this AC line. So then also we can able to find a new point. So here the 2 measurements which we should know is the length of the line AC and the angle of AC line with respect to our reference line AB. So or if you should have angles from both the end. You should have the angle at A, angle at B, and connecting them, you will be getting the new point. So this is the second principle, where in order to find out a new station, you should have 2 measurements. Either it should be a linear or angular or combination of any one of these. And coming to scale, there is normally in surveying we represent all the data which are collected in the ground. We will be representing it in map, in preparation of map or plan. So therefore, we need to choose a certain scale, because in the ground we will be collecting lot of details, and which will be in terms of kilometers, and we need to put them in a sheet of paper, in a drawing sheet. So in such case, what we will be doing, we will be normally considering the scales. So there are 2 types of scales. So one is engineer scale, or sometimes it is also represented with representative fraction. So in engineer scale, what we will be doing, we will be actually showing that the scale which will be measured in terms of, one is in terms of centimeters, another one is in in meters. That means here there is an example. The 1 centimeter represents, this is the scale which is used in the drawing sheet, that is for preparation of map, where 40 meter is nothing but the distance which is measured on the ground, actual distance. So here we can say this is like 1:40, which is representing in engineer scale in terms of 1 centimeter in the drawing sheet measures 40 meter on the ground, where the same thing can be represented in a representative fraction, that is both, whereas in both the units measured, that is the measurement of distance on the ground as well as the distance which is we are using, plotting it using the our map, in the preparation of map, all both should be represented in same unit, that is in centimeters. So this represents 1 centimeter on the drawing sheet is equal to 400 centimeter in the ground, which is nothing but, in other words, it is nothing but 40 meters on the ground. Okay, so we will be taking the ratio of this fraction of this will be considered, whereas in representing the representative fraction. So normally in the gate there will be question on this conversion of maps. There will be normally one question asked in the gate questions. And coming to errors, so there may be possibility of, there may be error due to the adoption of scales, or maybe due to the measurements of length itself. So there are 2 types. Either we may, at the time of doing field work, there may be some errors which may occur, or the errors may occur even at the time when we are actually plotting this into, when you are doing it in office work. The office work also you may end up with some errors. So basically this is the idea. So here we are actually concentrating on errors which is with respect to office, that is adopting some scales. So there is an example, let us see this. If a wrong measuring scale is used to measure the length of a already drawn line on the plan, then the measured length will not be correct. So that means if you assume some wrong scale, so meanwhile when you are plotting a plan, anywhere you change your scale, then there is this type of error will occur. So for example, if a plan has been drawn to an example for a scale of 1:200 and the length is measured with a scale of 1:250, there is some difference in adoption of the scale. So then how to calculate what is the actual length? So the formula is like you need to take the RF, that is the refraction fraction of that wrong scale. The wrong scale is here 1:250 is this is the wrong scale, and divided by RF of the correct scale. The correct scale is 1:200 multiplied by measured length. So whatever the length is measured. So if you take, say, so for example, some 250 meters are measured. So then the correct length of this will be, if you work out, you will get the actual length of that particular measurements. But if it is in case of areas, if it is the same with respect to areas, the same formula, you know that the area is nothing but the product of two distance. So normally if you take any rectangle or not or a square, it is like nothing but a into b. So you will be actually it's a product of two distances. So therefore, so we'll be squaring up this particular equation, which is already we have already discussed. So squaring it and measuring, multiplying it with measured area, we will be getting what is the correct area. So the formula remains same. Only thing you should remember is we are squaring up. So this same formula we will be using in chain errors in chain in order to calculate the correct length there. So let us take a look into the questions which are asked in the GATE examination. So here is a question: the representative fraction 1/2500 means that the scale 1 centimeter is equal to. So here actually they are actually asking, here we know that in the representative fraction both, which means here 1/2500 means it is nothing but 1 centimeter in the drawing sheet is equal to 2500 centimeter on the ground. So but normally in engineering we will be using, in the engineering scale, it is in terms of centimeters and meters. So if you convert this into meters, this particular value 2500 divided by 100, we get 25 meters. So the answer here is actually it should be 1:25. So it should be in terms of meters. You to find what is the actual ground length if it is measured 1 centimeter is measured on the map. So answer is C. Next, the plan of a map was photocopied to a reduced size such that a line originally 100 mm measures 95 mm, and the original scale of the plan was 1:1200. The revised scale is, so you need to find actually when they do the survey at the time the assumed scale is 1:1200, and the line which was drawn on 100 mm at the time, now it is due to shrinking of the map, it is now 95 mm. So there is a reduce in total length which we are getting. So then automatically when there is a reduction in measurements, we can say that the scale will actually, the revised scale will be more than this 1200. So if you observe this, if there is any options which is more than 1200 and the remaining are less than 1200, then you can directly take that option without solving the problem. So that should be you should have that basic knowledge on how to convert this. So here, so they are asking us to find the revised scale. So therefore, so the refraction the reduction factor for this will be actually 95 mm is the now the present measurement, and actual measurement is 100. So the reduction factor is 0.95. So therefore the revised scale will be, revised scale is what we want. So the revised scale will be equal to original scale into RF, that is reduction factor. So original scale is 1/1200 into 0.95. So you will get, if you solve this, you will get actually 1200 divided by 0.95, you will get 1263. So here the option for this correct answer for this question is 1:1263. So this is how we need to calculate the revised scale. So the revised scale is given by original scale into reduction factor. And coming to errors, especially in terms of when you are using chain as an instrument, there will be two possibilities, whether the chain may be too long or it may be too short. So directly we can actually take this. So that is the chain, if it is the chain is too long means, so for example, the standard length of the chain is 30 meter and the chain is too long means it should be more than this 30 meter length. So then the measured distance will be less, so which means if you are having long scale, the actual measured length, whatever we get is less. So therefore the error should be negative and the correction should be positive. So what we can summarize means, if the chain is too long, you can directly say that the correction is positive, and if the chain is too short, then the correction is negative. Okay, so that means the actual measured length, when the chain is too long, then the actual measured length will increase. Say for example, the measured length is say for example 200 meters, but if the chain is too long, it means our actual original length measured should be more than 200 meters. So indirectly we need to apply the correction, which should be positive, so it will be more than 200 meters. Similarly, if it is short, then if the same length is measured 200 meter in the field, then our final original result should be less than this. It should be less than this. So this is the idea, which means the correction is negative. And we know that whenever we have the this is nothing but the correction for chain. So that is given by L dash minus L by L into L dash. So here L dash is nothing but the actual original length of the chain, and L is it may be too short or it may be too long. So that means the original length will be 30 meters and the actual length may be lesser than that original length or maybe more than the original length. So this is the formula we use to find out the errors in chain. Coming to tape, so there are some 4 corrections which we need to apply when we are using tape as our instrument. So one is correction for temperature. So that is given by alpha Tm minus T naught into L, where Tm is nothing but the mean field temperature, and T naught is nothing but the standard temperature, which is taken as normally 27 degrees. And alpha is nothing but the coefficient of thermal expansion of the tape material, and L is the measured length. So this is either whether temperature is increased, then the correction will be positive. If the temperature is decreased, similarly the correction will be negative. So there will be both possibilities are there. Similarly, when we are considering the correction for pull, here P stands for the pull applied during the measurements. So normally we will be pulling the tape from either end, and where PS is nothing but the standardization of pull, means there will be certain amount of pull or certain amount of force needs to be applied in order to make the tape a straight one. So that will be called as PS. And A and E is nothing but the area, cross section area of the tape, and E is the Young's modulus for the tape, and L is nothing but the measured length. So this will be always positive. So that is the correction for pull, because we want to make the undulated tape by applying pull, we are actually making it a straight one. So thereby what happens, we are actually applying the tensile force. So thereby what happens, the length of the tape will increase. So therefore the correction here is positive. And correction for sag is always negative. So you should remember, this is correction for sag is always negative, which means the tape will be having this downward depression here. So that will be giving you actually the lesser values when compared with the normal straight stretched tape. So therefore this is the formula which is used for calculating the correction for sag. And the correction for slope is given by, it's also negative correction, so it is given by h square by 2l, and here h is nothing but the difference in height between the 2 points, and l is the measured length. And we have one more case in tape, that is normal tension. So that what is the meaning of this normal tension means, whenever we have this the tape in the sag portion and we need to apply certain amount of force here, we need to apply some certain amount of force in order to make this a tape which is in sag manner, which we have to make it straight. So how much force is required? So that tension force is calculated using the normal tension, which means the amount of force we are applying for the correction for pull should compensate with the correction for sag. So this should be equal. So then only what we can say is, if Cp is equal to Cs, then we can say that then the tape is correctly stretched and we are having no error in terms of measurement of distance using the tape. So this is the basic idea. So here we'll be interested to find out, sometimes there will be a problem asked on this. So the specific weight of the tape will be given, and the standard pull required for the tape to stretch is also given. So normally they will be asking to find what is the actual tension we need to apply in order to make the tape tension free. So that is the normal tension which we need to calculate. So the basically on errors, so there will be this type of questions will be asked in the GATE exam. So this is a question, read, a 30-meter metric chain is found to be 0.1 meter too short. So the point to be noted is, it is too short. And throughout the measurement, if the distance measured is recorded as 300 meter, then the actual distance measured will be. So actually, if you observe the question, because the tape is too short, so we can actually conclude that actual measured distance will be always lesser than the measured distance. So we have already discussed this. If it is short, if it is too short, then the actual distance will be lesser than the measured distance. So that means in this case, our actual distance will be less than measured distance, that is 300. So without solving, we can say, if you look into these options, all the options A, B, and D are more than 300, but except option C. Option C is less than 300. So we can check for this option, that is the correct answer. But in case for surety, we can solve this. That is actual length. So that means, so let us solve for this question. The actual length of the chain. So actual length of the chain will be, actually, because it is 0.1 meter. So therefore, actual length of chain is 30 minus 0.1. So because it is too short, so we need to deduct. So therefore, actual length of the chain is 29.90 meters. So therefore, actual distance is given by, the actual length of the tape, that is 29.9, by the standard length of the chain, that is 30 meters, into measured distance. So on solving, we get this 299.00 meters. So that means the option C is the correct answer. So that means if you are smart enough, if you observe the questions carefully, if it is too short, if that means the actual distance will be less than the measured distance. So we can go for the answers directly. If there is two options lesser than 300, then you have to work out the solution for such questions. Moving on to next question. So here is a 100-meter tape is suspended between the ends under a pull of 200 Newton. And the weight of the tape is given as 30 Newton. The correction for sag and correct distance between the tape end is. So here we should know that this is, we are actually considering calculating the correction for sag. So one thing you should know that the correction for sag is always negative. So which means whatever the tape, the measure distance 100 meter we are actually having, which means if the tape is having the error due to sag, then the correct distance, will be less than 100 meters. So if you observe the options here, only these two options are having the correct distance which are less than 100 meters. So that means you no need to calculate what is the correct distance. If you calculate what is the correction for sag, if you calculate out of these two which one is the correction for sag, what according to this problem, then we will be actually getting the correct answers here. So that is the correction for sag is given by, it's always negative. So W square L by 24 P square. So where W is nothing but the weight of the tape. The weight of the tape here is 30 Newton, and the length of the tape is 100 meters, and P is nothing but the pull. The pull which is applied at the end is 200 Newton. And by solving this, we will be getting the answer. It is negative 0.094 meters. So which means, so we can say that directly the answer for this question is option B. But you know that this is negative correction, therefore the correct length, the correct distance will be equal to, so therefore you can say the correct distance will be, the second one is the correct distance is, or the actual distance is equal to 100 minus the error due to sag, that is minus 0.094. So by doing that we will get 99.906 meters. So that is nothing but the second option, 99.906 meters. So if you have identified the correct length should be less than 100, then out of these two any one will be the correct answer. So like this we need to calculate the correction for sag and the correct distance for the distance between 2 points using the tape. And moving on to the next topic, that is compass. So normally in the GATE exam there will be a question on calculation of bearings. That is the main purpose. So what is instead of going into the in-depth knowledge on the bearings and all the basic definition, so let us have a look into the concept oriented. In the whole circle bearing, we measure the bearings in two ways. That is, in the compass, using the compass, we have two types of compass, that is prismatic and surveyor compass. And in the prismatic compass, the method adopted is whole circle bearing. In the surveyor compass, it is quadrantal bearing. So the difference is, in the whole circle bearing, always is north line. So we'll be measuring the angles with respect to north. Whereas in quadrant bearing system, it will be divided into 4 quadrants, and between those quadrants we will be measuring the distance. So here in between, if it is here in the first quadrant, then we will be measuring north, theta, east, means in between the two directions. So it is always in between north and south as taken as here 0 degrees, and the east and west sides are taken as 90 degrees. So each quadrant varies with 90 degrees, 0 degree to 90 degree. So within that we will be measuring the bearings. And coming to the next important topic on compass is declination. So normally there will be a question in the GATE. So there will be two cases. So what is actually declination means? Declination is nothing but there will be a difference with respect to the actual true bearing with respect to the magnetic bearing. So that is, the true meridian will be our true north of the earth, and the magnetic north will be the needle which we are using, the magnetic needle what we are using in the compass, that will be showing in the difference way. So therefore the difference in angle between that true bearing or the true meridian with respect to the magnetic meridian is called as declination. Either it may be towards east or it may be towards west. So if it is towards east, so we'll be calling it as positive, that means it will be towards right side. And if it is moving towards the west side, then we'll be considering that as negative. So that means we need to use this corrections needs to be applied in order to convert the bearings from true bearing to magnetic bearing. So moving on to the questions asked in the gate. Here is a question: if the forebearing of a line is 35 degree and of the line BC is 15 degree, then the included angle between the line is. So here they are asking us to find the included angle. So it's better to draw these and calculate the included angle. So here is the line AB, and the line AB is 35 degrees, and BC line is 15 degrees. So therefore they are asking us to find what is the bearing or the included angle here. So they are asking us to find the included angle. So what is how to calculate the included angle? So here the back bearing of this line will be 180 degree plus 35. We know that the back bearing of any line will be, because the observed forebearing of AB line is less than 180, we need to add that bearing to 180. So we get back bearing is 215. So we need to calculate this included angle, say some alpha. So that will be equal to, actually it will be equal to 360 degrees. So this 360 degree is, we are taking the complete whole circle bearing, 360 degree minus 215. So out of that, if we deduct 215, then the remaining bearings what we are getting is only this much. Okay, so but we want alpha, that alpha is not equal to this, so we are only going to get some angle which is say beta, but we want actually the alpha angle. So for that we need to add 15 degrees. So picturize, always draw the figures and picturize them and calculate the included angle. So by solving this we get 160 degrees. So option C is the correct answer here. And so why we have to take the other side, this side only? We would have taken this other side here also. Okay, if you calculate this answer, this answer will not be available. There will be two possibilities, because the direction of survey is not mentioned, whether it is clockwise or anti-clockwise. So therefore, if you calculate the included angle on the other side, you will not get that option here. So therefore, you have to check for both the direction, then you have to select the options. So like that, the questions will be asked. And coming to the questions on declination. So it is a question: an old map, a line was drawn to a magnetic bearing of 10 degree 30 minutes. The magnetic declination is 2 degree east at that time, and the magnetic bearing to which the line should be set now, if the present magnetic declination is 4 degree 30 minutes. So we need to divide this into two parts. The old time it was having 2 degree east error, now it is 4 degree 30 minutes west. So the declination is as varied. So in the first part, so we had, this is our true meridian and this is our magnetic meridian, and the declination between, the difference between angle between the true meridian and the magnetic meridian is 2 degree east. So that's why we are taking towards east 2 degree. And at that time when the bearing was measured with respect to the magnetic meridian, so this bearing, so they mentioned it is magnetic bearing, so that is 10 degree 30 minutes. So therefore, by this we can calculate the true bearing. The true bearing will be always equal to, that means true bearing is nothing but the bearing measured with respect to true meridian. So that will be equal to magnetic bearing plus declination. Declination here is 2 degree. So magnetic bearing is 10 degree 30 minutes. So therefore true bearing will be equal to 12 degree 30 minutes. So this is the true bearing. So one thing we should know, the true bearing is not going to change over any time. So that is going to be constant. Coming to the second concept, that is, we are actually calculated the true bearing. So that, so the true bearing is true bearing calculated degree 30 minutes. Coming to the second part now, so we need to calculate what is the actual magnetic bearing which should be at present situation. So for this, if you have this true meridian, and the magnetic meridian is now 4 degree 30 minutes west. So this is the magnetic meridian, the declination is towards west. So this is 4 degree 30 minutes. But we know already what is the true bearing. The true bearing is measured with respect to true meridian is 12 degree 30 minutes. So we need to calculate the magnetic bearing, means always the magnetic bearing is measured with respect to magnetic meridian. So we need to calculate this. So therefore, magnetic bearing here will be equal to true bearing plus declination. Why we need to add declination? Because if you observe carefully this figure, we need to add 4 degree 30 minutes plus 12 degree 30 minutes in order to get the magnetic bearing. So that's why we are adding. So therefore, by adding, we get the total magnetic bearing will be equal to 17 degrees. So therefore, the option A is the correct answer here. So we need to subdivide this whole work into two parts. One is you have to calculate the true bearing with the first data set of data in the old map, and in the second we need to take this further for the new current situation. For the present situation, we need to calculate the magnetic bearing. So these are all the few questions which are normally asked in the compass. So moving on to leveling. So we know that till now we are actually interested in calculating the horizontal distance and the horizontal angles. Now we will be moving on to find the vertical distance. So therefore, in leveling, what we will be doing, we'll be interested to know the elevation. So that is the measurement process whereby the difference in height between the 2 points, we are interested to know the difference in height. So here to take any 2 points, so we'll be observing the readings. So the first reading, whatever we take on the known RL is called as backside, and the last reading taken with respect to that instrument is called as foresight. So if you take out that, so basic knowledge about this we will be having. So without wasting our time here, so what the type of questions we will be expecting here is, they will be asking you to find the RL, reduced level of certain point, that is especially when the staff is held invertedly. And there will be a question normally on correction for curvature and refraction. So the correction for curvature is always negative. So that means when we consider the curvature into account, so this is the line of sight. So we'll be normally observing more values than the actual one. So this is the actual reading what we need. So that this is the additional reading what we are reading actually, that needs to be deducted. So therefore, the correction for curvature is always negative. So the curvature correction is given by this formula, that is 0.07849 d square, where d needs to be substituted in kilometers. So please remember, the d is nothing but the distance measured. Whatever the distance we measured, it should be substituted in kilometers. Then we get the corrections in terms of meters. Okay. So therefore, similarly, the refraction correction is due to variation in light. So therefore, the correction needs to be applied for the refraction is, we need to apply a positive correction. That is, we will be observing the values normally lesser than actual one. So therefore, the correction here will be positive. So that will be given by, that is the refraction correction is given by 0.01121 d square. And here also please note that distance measured should be substituted in kilometer. And the combined correction means combination of both this curvature and refraction correction. So which will be normally used with this equation, that is 0.0673, which we take out the difference between these two, we will be ending up with 0.0673 d square. Here also d is substituted in terms of kilometers. So there will be a question on this correction for curvature and refraction in the GATE exam. Normally will be asked whether to calculate the correction for curvature or correction for refraction, or sometimes both combined correction will be asked. And moving on to next important point in leveling is reciprocal leveling. So this is where we'll be adopting this reciprocal leveling when we have 2 points and the 2 points is having far distances, having more distances, and we need to calculate, we need to know what is the true elevation of each of these two stations. So in such case, normally when we have a stream flowing, so normally on either side of the banks, we will be going for this type of leveling work, that is reciprocal leveling. So in the first stage, we will set up our instrument near to A and observe the reading at A and B. So let us say the values of reading which we take from when the instrument is placed near to A is HA and HB. And when you shift the instrument from near station A and shift the instrument and place it near station B, and again you will be observing two readings, that is one at B, another at A. So that will be calling it as representing with HA dash and HB dash. And if you take out the difference between two observation, and if you take the mean value of this two observation, which is going to give us the true difference. So that is the true difference. When if you go further, so there may be a question, what is the error in collimation? So what is the error in collimation? So the error in collimation is represented with E. So we use the same equation, that is HA minus HB. Instead of adding both these, we will be deducting. So put negative HA dash and HB dash. So by doing this, what we get is nothing but the error in collimation. So if in the code gate, they ask you to find what is the error in collimation, what is the total error. So you have to use the same formula but with the negative sign. So this is the concept behind the reciprocal leveling. So let us look into some problems asked in the respect to leveling. So the question is like this: the RL of the point A, which is on the floor, is 100 meter, and the backside reading on A is 2.455 meter. If the foresight reading on point B, which is on the ceiling, is 2.745 meters, the RL of the point B will be. So we need to calculate what is the RL of point B. So here, so let us plot this into a drawing. So we have recorded, observed the backside at point A, and the RL of this point A is 100 meters, right? And the backside reading taken at that point A is, this height is 2.455 meters, and the second point B is actually taken on ceiling. So in the ceiling, the slab will be held invertedly. So that means here this is the point where the staff is having zero reading. So this is point B. So this reading is observed reading is 2.745. So if you observe carefully here, because the given RL is 100, so we need to calculate what is the RL of B point. So therefore RL of B point will be equal to RL of A, which is 100, plus backside, which is 2.455. And because it is the staff is held invertedly, we need to add this distance also. So that means we need to add this distance in order to find the RL of the point B. So normally when we have this case, when the staff is held invertedly, we need to add all the readings. So either of these two will be correct one. But when you look into these two options, both are more than 100, but this particular C option is having only 0.29. But when you observe these two readings, which are actually 2 meters, more than 2 meters, so we can actually go for this D option, or you can calculate, add the RL, take the RL of point A, add the backside and add the foresight, or the reading taken at the ceiling level. So then we will get the actual RL at point B. So option here, the correct answer is D. And moving on to next question is, a level was set up at a point A and distance to the staff station B was 100 meter. The net combined correction due to curvature and refraction as applied to the staff reading is. So they are actually asking us to find the total combined correction of both curvature and refraction. So we have already seen this, that is the net combined correction is given by, that is the net combined correction is given by its negative correction 0.0673 d square, and d should be the measured length in terms of kilometers. So the measured length here is 100 meters. So therefore, so convert that into kilometers, that will be 0.1 kilometers. So substituting that 0.0673, 0.1 0.00673 meters. So whatever may be the measured length here, we need to substitute that in terms of kilometers. Always this should be in terms of kilometers. So after that only we'll get the correction in terms of meters. So therefore here the correct answer is option number D. Correct? Yeah, option number D. That is minus 0.00673. Okay. There may be a problem on separately on correction for curvature and refraction, but normally this net combined correction will be asked in the gate exam. So what change they may make is the measured length will be varied. And moving on to next one, that is the 2 points A and B are 1530 meters apart across a river. Then find out what is the true difference in level between A and B. So we need to find what is the true distance between, that is true elevation, the true difference in elevation between the point A and B. So it is very simple. That is, you take out the difference in reading between the 2 points when the instrument is located near A, and again take the difference between the two stations readings taken when the leveling instrument is at B. So thereby, and take the average of this difference. So that will be giving us the actual true distance. So that is here. So if you calculate, the difference between these two will be, so here it is, this is 1.645. Okay, and the second with respect to other one, it is equal to 1.445. So if you take the average value for these two, so the average of these two will be the true elevation, that is 1.645 plus 1.445 by 2. So by solving we get it is equal to 1.545. So this is the correct answer. Because you can observe, you should not go further, because you can stop it here only if you observe the options, because one is 1.645, another one is 1.455, so this will be eliminated, and these two, there will be possibility that, because if you take the average, these two are actually less than the least difference, that is 1.445. So the value which is in between these two is only option C. So you can actually, without wasting your time, you can select the option C in this type of problem if such type of options are given. And moving on to curves, normally there will be a lot of questions which are asked in compass and leveling work, but in recently now the curves are added. So there are basically two types of curves we see, that is, one is horizontal curve and the vertical curve. And in the horizontal curve, we have three different types, that is simple curve, compound curve, reverse curve, and also there is another type of curve called as transition curve, where the radius of the curve is going to change by point. So each side it will be varying. And the transition curve is further, we have three different methods, that is cubic parabola and spiral curve and Laminscale curves, which are comes under transition curve. So, and in vertical curves we have two types, that is summit curve and valley curve. Whereas in with respect to curves are concerned, the questions related to two straight lines, that is normally they will be asking us to find what is the length of the chord and the mid-ordinate method. There is only one probable questions which are asked in the curve, so you may expect most probably the questions which will be on the mid-ordinate methods or chord produced methods like that. So here is a problem. Two straight lines deviate at an angle of 50 degrees. The radius of a curve joining the two straight line is 500 meters. The length of the long chord and the mid-ordinates in meters of the curve are. So we need to calculate. So what is the length of the long chord and the mid-ordinate for the respective chord? So the length of the chord is actually given by the length of the chord. Here the angle is deflection angle is 50 degrees, and the radius is 500 meters. So therefore the length of the long chord is, so the length of long chord is given by 2r sine theta by 2. So here r is nothing but the radius. So the radius is 500 meters into sine theta by 2. So theta value is 50 degree by 2. So on solving, we get the length of the chord will be equal to 766.04 meters. So without calculating the mid-ordinates, we can select option B here, because that is the only option which is having 766. That is a smart way to look into. But in GATE, normally they will repeat the same. Here you may have another option which could be having same values. If so, then we need to calculate the mid-ordinates also. So therefore, how to calculate the mid-ordinate? So mid-ordinate is calculated using, that is, the mid-ordinate is given by that is r into 1 minus cos theta by 2. So therefore here the radius of the curve is 500, and the theta deflection angle, that is the theta angle is measured angle is 50 degrees. So on solving this, we get the mid-ordinate, that is the length of the mid-ordinate is equal to 46.85 meters. So if you have both the options are of say 766, then you need to find out what is the mid-ordinate. So it is, the correct answer for this is option B. Okay. So therefore, so these are all the normally the questions which are asked in the GATE exam. So there is, so I will say thank you for your patience listening. And for a civil engineer, there is no such thing as a little mistake. So means when you're doing a survey work, if you end up with properly, if you're not connecting the 2 points properly, then we need to go for accurate work. So there is no two sides of the bridge, so that we get a proper construction execution of work is properly done. So related to the question, in slide number 9, why not A instead of C? So I will go to okay. So that that is okay. There is a error here. This is actually given as 0.25 meters. Okay, all right. This is 0.25 meters. So that is C is the correct answer. 25 meters. Next, in slide number 10, why can't we use the previous formula? Where in slide number 10? Because here the concept is actually you have one set of scale, original scale, which is already used, which is 1:1200, and using that they have plot some 100 mm line on the map. but now that line is actually, this is actually, we are actually not what we are actually calculating. If they have measured that 100 mm in the previous case, but now it is measuring it as 95. So that means we need to calculate the revised scale. So we cannot use the previous formula, which the previous formula which we used is for calculating from, just to represent that from representative fraction to engineering scale. So the engineering scale is normally used, preferred in the one, the first value always represents the the line, the distance of the line in the drawing. So this is in the drawing. This 25 meter is always measured distance, measured length in the ground. So actual length measured on the ground. So 25 meter on the ground will be equal to 1 centimeter in the drawing sheet. Whereas here they are asking us to find the scale for this map, which is which has shrunk by, say, from 5 mm here. So for that means if it has reduced, that means the scale will increase. So the scale is going to increase. Okay, next question is, what is, I told what is PN. PN is nothing but the pull which is applied during the standardization, means, which is the slide number 12. Okay, let me clear all this. Okay, here this is the question. What is actually meant by PN? So the PN is nothing but the pull applied during the measurements. Here the pull applied during the measurements, where P0 is nothing but the standard pull, the standard pull required in order to make the tape should not get have the sagging in nature. So that is, then slide number 17. There is slide number 17. Okay. How is 180/35? So you are actually using the deflection angle method. That is, if you add 180 degree plus 15, sorry, plus 35 degree, so we get, so this is calculation of back bearing, the back bearing of BC line. So this is the back bearing of BC line. So the back bearing of BC line is 215 degree. So let me clear this point. Let me erase. See here, the forebearing of that line is 35 degree, the AB line. So therefore, the back bearing of this line will be, we need to add back bearing will be, we know this, the forebearing is always, or you can say back bearing is always equal to forebearing plus or minus 180 degree. If the observed forebearing is less than 180 degree, in this case it is less than 180 degree, we will need to add 180 degree. So therefore, the back bearing of AB line will be equal to, that is, observed 180 degree plus observed forebearing, that is 35. So we get 215 degrees as the back bearing of AB. So once you know that, then we can calculate what is the included angle for the next line. So they are asking us to find what is the included angle. So this included angle we need to calculate. So that is back bearing. And then slide number 23. Now we are getting, okay, if it is 3 zeros, then make the correction, because if you solve this, if you are getting point, whether it is 0.0067, wait, 0.0673 into 0.1 square. So it will be equal to, yeah, it is correct. This is the correct answer. So I missed 10 here. So 0.00673. Please note that here always the D should be substituted in terms of kilometers. Then formula in slide number 8. Okay. I not got the question which we use to find actual length of the object. Yeah, the same. This is the same formula which we calculate. We use to find the actual length, but we can use the same in order to find if it is given in terms of scaling. Okay, that is if the observed the taken scale is having correct length, and we have plotted that with a different scale. While conducting survey, we have taken some scale, and when we are plotting, we will be using different scale. Then there will be mistake in plotting. We will be actually having some error in the measured length. So that is the case here. What we are discussing. Of course, there is the same thing which we can use. As I already pointed out, we can calculate the actual the actual length here. The correct length will be given by, that is L dash by L into L dash, where here we can take this L dash as nothing but the error in the chain. Then this is the actual length of the chain. So that is maybe 30 meter, 20 meter chain, and depending on that, depending on the error, it may be too short or too long. Based on that, we will be calculating the correct length. So this is actually we can say this is L, that is say measured length. So here it is measured length. So the measured length is, say for example, so we have saw that problem in errors. We have taken that first problem is based on that formula. This is the same formula which is we are going to use. That is error in chain, actual length of the chain, measured length. By that we'll get the measured length is 300. So by that we'll get the actual length of the chain. So therefore, this is the hope this is no doubts there. Okay. So with this, if there are any queries needed, you can put the questions in the chat box. I'm happy to answer to that point. And the rest of the concept will be explained by my colleague, that is on coming days by Professor Girish P on remote sensing and GIS and GPS applications in surveying. That is in preparation of mapping and how to take whatever the expected questions in the gate will be covered by him. So with this, I will take this opportunity to thank everyone and all the best for your gate examination. Do well. Over to Rajit sir.
Thank you, Professor Anjan. It was very informative session. So dear past participant, please find the link for the session feedback and provide your valuable feedback. And I request all the participants to join us on day 6, that is on tomorrow, 1st December at 2 p.m. On that day we have two sessions. Session 1 by soil mechanics, subject soil mechanics by Professor Chaitanya, followed by session 2 by Professor Madhushri C on hydrology and irrigation engineering at 3:45 p.m. using the same YouTube channel. Thank you. Thank you all.